Now that we've learned how to do the simulation in this instance, how do we come up with a p-value? So remember that the correlation coefficient was 0.474. So basically what I'm asking is, if I assume through my simulation that there is no association, how likely would it be to get a correlation at least as extreme as 0.474 in both directions, so also negative 0.474. So I want the computer to count how many dots out of 1,000, how many correlation coefficients out of 1,000 simulated ones were at least as extreme as 0.474. Now, as per usual with the applets, it's the count box that we use to figure out the p-value. So into the count box goes the what's considered our statistic in this case, the correlation of 0.474. And I'm using beyond in the drop-down box. So let's go back to the applet for a moment. In the drop-down box, the default is greater than. We also have less than and beyond. When it comes to this alternative hypothesis that there is an association, we're always going to use beyond. And when I put in 0.474 and use the count box, it came up with 6 dots out of 1,000 that had a correlation at least as extreme as 0.474. So my p-value now when I did this earlier, it was 4 out of 1,000, so I'm just going to stick with that because it matches what I have written underneath. The first time when I did my shuffles and deals, remember everybody gets, well, not everybody, but we get different p-values when we use simulation, and that's okay. So pretend it said 4 out of 1,000 instead of 6 just now. Okay, so with a p-value of 0.004, there is very strong evidence against the null hypothesis. So the same guidelines that we used before in terms of strength of evidence, they still apply. So here it asked us to interpret the p-value, okay, and that's the sentence in yellow. This is the interpretation, the probability of what, assuming what, that's how we interpret the p-value. So there is a 0.004 p-value chance of seeing a data set with a correlation at least as extreme as 0.474, assuming there is no association between finger length and height. So notice that it doesn't say assuming the null hypothesis is true, because it asked us to interpret the p-value, which means in context. As soon as you see the word interpret, that automatically means in context. So I don't want to just say there is a 0.004 chance of seeing a correlation at least this extreme, assuming the null hypothesis is true. I want to explain in this instance, so a correlation of at least 0.474, assuming no association between finger length and height. Now, we could state our strength of evidence against the null hypothesis first. That's what I did. But then we can also summarize the conclusion, right? So in yellow, I interpreted the p-value. And then in green, to summarize the conclusion, that's the last sentence. The data provide very strong evidence that there's an association between finger length and height in the population. So again, this is specific to this scenario about finger length and height. And so I want to talk about the data provide very strong evidence that the alternative hypothesis is plausible, right? So if we have very strong evidence against the null hypothesis, that means the alternative hypothesis is plausible. That means the strength of evidence I have is for the alternative hypothesis, and that's the way I word my conclusion in context. There's very strong evidence of an association, in other words, that the alternative hypothesis is plausible.